Hello everyone, my name is Missie Huang and I am here to talk to you guys about our project called a Plasma Vortex Speaker. So I am doing this project with Ahmad, Riza, and Webo. Let's get started. So first is the outline. I will first talk to you guys about the introduction, the diagram block, the results of our experiment, and lastly, the conclusion of our Plasma Vortex Speaker. So, currently, the interest in the use of plasma are steadily increasing for many fields. So, such fields that we can name are like industrial field, medical field, entertainment field. So, all of these or other types of industries, they are all having more interest in the use of plasma. And so, therefore, for our project, we plan to generate a plasma vortex speaker as an example of how to generate plasma. So, first, what is a plasma vortex? A plasma vortex is a state-of-the-art oxidation system that is used to facilitate cost-effective wastewater decontamination. So this is an example of a very popular way to use plasma vortex. So they use it as a way to decontaminate water. The application range from groundwater remediation, cruise ships, agricultural irrigation, industrial manufacturing, to individual housing applications. So these are just some applications of plasma vortex. And as you can see from the right, this is an example of a video that we follow, a picture of a video that we followed in order to create our plasma vortex. So, an electrical arc or an arc discharge is an electrical breakdown of a gas that produces prolonged discharge. The current through a normally non-conductive medium such as air produces plasma. So here, the vortex is generated when the electrical arc glides along the surface of the two electrodes under the effect of the Lorentz force. So as many of you guys already know, the Lorentz force is the relation between the direction of the magnetic field and the direction of the current. So if you have, since electrical current flows from positive to negative, if you have your positive, a positive electrode on this side and your negative here, the current will flow up and the direction of the magnetic field will be counterclockwise, like this. So in our experiment, you can do it either way. So if you put the positive at the top and the negative at the bottom, the only difference will be the direction of the arc that is produced. So the direction of the vortex that is produced. So the arc will rotate in the same direction as the magnetic field. So if the electrical current flow is from here up, then the arc will rotate counterclockwise, and if it's the current is from up here to downwards, then the direction will be clockwise. So here is a diagram of our design. We have the electrode rod in the middle going through the magnetic ring, as you can see, and a power supply will be connected. Here are some of the materials in our diagram block. So a phone audio is connected using an audio jack. And then this is connected to a speaker and to our circuit, and the circuit is then connected to a power supply and our plasma vortex. So this is our electrical design. So as you can see here, this is the connection that we used on our Arduino, and yes. Okay, so in our flowchart diagram, in the beginning, you need to first declare the variable. So this means that you need to declare which link or pin you will connect the audio jack to, and then that is where you will. So in the beginning, you have to declare the variable first, and then afterwards, you need it will read the analog data from the audio output. And you need to set the threshold. So in our project, we set the threshold to 25. So anything over 25, it will read the signals and it will turn on the plasma. Anything under 25, then it will not turn on the plasma. So as you can see here from our table, you can see values at the left as the analog data. So anything over 25 or over 25, it will read and it will turn on the plasma. So anything below 25, it won't read. So it won't turn on the vortex speaker. So that's all that this means. Next is, these are some of our experimental results. So in order to check our plasma vortex, we use different types of rods and different types of rods and different diameters. So as you can see, the main difference between all of them are the rod diameters. So as you can see in test number 1, most of them, the plasma arc will turn on, but the arc will not rotate. And that's the big part of our project, is that we want the arc to be rotating. So even any diameter, all of them still opens, turns on the arc, but the arc does not rotate. So as you can see from our experiment, only experiment number 9 and experiment number 10 generates a rotating arc. So as you can see from between 8 and 9, maybe you will notice that both of them have the same rod diameter. We use 3.41 millimeters for both experiment 8 and experiment 9. But the only difference is that experiment 8 uses a flat edge and experiment 9 uses a pointed edge. So as you can see from these two pictures, this is the rod used for experiment 8 and this is the rod used for experiment 9. So the only difference is the tip. So there are a lot of parameters that we do not know specifically why it changes the arc rotation, but as we have tested, it does affect the rotation. So as between 9 and 10, experiment 10, it did rotate, but the problem was it was not as stable as the thicker diameter rod. So yes. These are our first results. This was our original results. As you can see from the video, there is the spark that is the plasma vortex. And if I turn on the audio, it is pretty loud because I think in the beginning the threshold that we used was lower, so it was reading more of the output signal. And here you can see the experiment number 10. So in experiment number 10, you can see that in experiment number 9 could rotate the arc better than experiment number 10. So let's play that again. And here, yes. Okay, let's move on. So these are our current results. So these are the latest results that we have using the 3.41 millimeter rod. As you can see, this one is without audio. We haven't connected it to our music output, so it's just us trying to generate the arc. So as you can see, the rotation is much better, and in this video you can see the rotation better. So yeah, this is what it looks like currently and with a threshold of 25, and this one is the one connected with the audio. Let's see that again. Okay, so as you guys can see, the audio output does affect. As the audio goes higher, the rotation is much stronger. That's because the Arduino reads the signal of the music and then turns on the plasma arc. Okay. Oh no. Okay, so conclusion. The plasma vortex can only be generated with a certain rod diameter. But what we mean by this is that depending on the rod diameter, it rotates differently. But based on our experiment results, any diameter would still turn on the arc, but it will not rotate. So next is the ratio between the inner diameter of magnet ring and the rod will affect the arc generated, because as you guys can see, the magnet that we used here was significantly smaller than the magnet than the picture we put in the introduction. That's because this is it's the ratio between the magnet ring and the rod that makes that affects the arc generated. So yes, thank you guys for listening to our presentation.